Imagine a machine that sorts thousands of tiny, complex parts every hour without a single computer chip, camera, or sensor. It sounds like science fiction, but it is actually pure physics in action. We are diving into the world of vibratory bowl feeders and passive mechanical sorting. These systems rely entirely on the geometry of the object and the laws of motion to achieve 100% accuracy. While modern industry often defaults to expensive AI and high-speed cameras, these mechanical marvels prove that sometimes the simplest solution is the most effective. Today, we reveal how these machines use gravity and shape to master order from chaos. The secret starts with a very specific type of movement. The bowl does not just shake randomly, it vibrates at a precise frequency, usually around 60 Hz, in a three-dimensional arc. This creates a phenomenon called micro-hopping. Every tiny vibration tosses the objects forward and upward along a helical track. Because the bowl is slanted, gravity constantly tries to pull the objects back down, but the frequency of the 60 Hz vibration is tuned to overcome that pull, forcing the objects to climb the walls in a single file line. This is the foundation of mechanical transport without a conveyor belt. Once the parts are moving, they encounter traps. These are carefully engineered cutouts and obstacles built directly into the track. Think of it like a lock and key. A bolt that is 10 millimeters wide will pass over a 9 millimeter gap, but a smaller 8 millimeter screw will fall through the gap and return to the bottom of the bowl. By placing a series of these geometric filters, the machine can weed out any part that does not meet the exact specifications. The track itself becomes the computer, calculating the dimensions of every part using nothing but physical space. Sorting by size is one thing, but what if all the parts are the same size but facing the wrong way? This is where the machine gets clever. Engineers design profiles that only allow an object to pass if it is in the correct orientation. For example, a bolt might hit a narrow wiper blade. If the bolt is standing upright, the blade knocks it back into the bowl. If it is lying flat, it passes underneath. By the time the parts reach the end of the track, every single one is facing the exact same direction, ready for the assembly line. For asymmetric parts, we use the center of gravity to our advantage. If a part is top-heavy, the track might feature a narrow ledge. A part oriented with its CG over the ledge stays balanced, while a part oriented the opposite way becomes unstable and falls. This allows the machine to distinguish between the front and back of a part that looks nearly identical. It is a calculation performed by gravity itself. By manipulating the surface area and the pivot point, we ensure that only the correctly balanced objects proceed. Why use this instead of a high-tech camera system? Efficiency. A digital sensor has latency, the time it takes to process an image and trigger an air jet to blow a part away. A mechanical sorter has 0 milliseconds latency because the decision is part of the movement. Furthermore, these machines require no software updates and can run for decades with minimal maintenance. In the time it takes an AI to identify one part, a mechanical feeder has already sorted dozens. It is the ultimate expression of simple is better in engineering. These machines are the backbone of global manufacturing. In the pharmaceutical industry, they sort 10,000 capsules per hour, ensuring not a single one is crocked or upside down. In automotive plants, they feed millions of nuts and bolts into robotic arms with flawless precision. Because they can be made from food-grade or medical-grade stainless steel, they are perfect for sterile environments where electronics might fail or accumulate dust. They are the hidden workhorses behind almost every mass-produced product you use. The next time you see a perfectly assembled product, remember that it likely began its journey in a vibrating bowl. Passive sorting reminds us that understanding the fundamental principles of physics can solve complex problems more reliably than the most advanced software. Engineering isn't just about adding more technology, it's about using the natural world to your advantage. By mastering geometry, gravity, and friction, we can create machines that work perfectly, forever, with no sensors required. That is the true beauty of mechanical logic.